Hi, welcome back to General Chemistry 1. I'm Dr. Fang Xu. Let's talk about balancing chemical equations. So what is a chemical equation? Chemical equation is something reflecting what reactants, what chemicals we put into a chemical reaction, and what products we get. It means an equivalent exchange between reactants and products. Not everything is conserved before and after a chemical reaction. What is conserved is the total mass and the number of atoms, number and type of atoms before and after reaction. In terms of number of molecules and physical status of reactants and products, this may or may not be conserved. It's not a requirement. Let's take a look at an example of hydrogen reacting with fluorine to form a hydrofluoride. When I say total mass, what I mean is everything of the reactants. Reactants refers to the chemicals before reaction, and product is chemicals after a chemical reaction. Okay, so for the total mass of reactants, you use 2 grams plus 38 grams, then it's 40 grams. After the reaction, the total mass is conserved is 40 grams. So there may be a little bit, change in the mass after 2 points of 2 to 3 digits after decimal, and those can be ignored. Okay. So total mass is conserved. Also, if you look at the number and type of atoms, before we have 2 hydrogen and 2 fluorine. After reaction, we also have 2 hydrogen and 2 fluorine. Remember, the 2 applies to all of the atoms in the compound, in the formula. So in terms of number of atoms in hydrogen and fluorine, the number of and type of atoms are conserved. And based on this, we can balance the chemical equation. And let's just go through it step by step. And when we say basic chemical equation, first we'll have the formula, correct chemical formula of all reactants and products. What we need to do is to fill in the coefficient before each compound, before each chemical formula. So for example, here we have this unbalanced chemical equation. All the coefficients are missing, and we need to figure out what numbers we need to fill in there. So for unbalanced equations, first you need to make sure is to get the correct chemical formulas. If formulas are wrong, you are not going to get a correct balanced chemical equation. So make sure you have a good foundation to start with, get the correct chemical formulas. Then we can count the number of atoms for each element before and after reaction. For example, here, carbon, we have only 1 carbon before reaction, okay? But for hydrogen, it showed up in 2 different places. We add them up. So in total, we have 4 hydrogens here. Also for oxygens, they come from 2 places. Add them up, we have 3 oxygen atoms. After the reaction, we have 1 carbon, 2 hydrogens, and 3 oxygens from 2 places. So in this chart, you can know the type and number of atoms before and after reaction. The carbon have the same number before and after reaction, so does oxygen, but hydrogen has different numbers. So we need to change coefficient or coefficients before some of the chemical formulas, so the number of atoms can match exactly before and after chemical reaction. So what we're going to do is we need to give more hydrogens after reaction. The only place hydrogen show up as a product is here as water. So we give it 2, put the 2 here as a coefficient to match for the number of hydrogens. So here we have some warnings. When you put the coefficient in front of a chemical formula, all atoms in the formula are changed together. So when you put 2 here, the hydrogen is doubled, the oxygen also needs to be doubled. and the default coefficient is 1. For the blanks we did not fill in, we'll assume it's 1 there. All right, after filling the 2 here, we changed number of hydrogens. So now we have 4 hydrogens in product. But also we change oxygens, number of oxygens. So in total, after the reaction, we have 2 plus 2, that equals to 4 number of oxygen atoms. Okay, carbon is balanced, hydrogen is balanced. Well, we introduced 1 more oxygen atom and we need to balance this oxygen. So we need to repeat step 3 many times and tuning the coefficient until all atoms are conserved before and after reaction. So in this case, we need to tune the oxygen before reaction. Now here comes to the question. There are 2 places we have oxygen. Which coefficient shall we tune? Now let's take a look at this table. All carbon, both carbon and hydrogen are conserved. The only thing that is different is oxygen. So if we change coefficient of methanol, we also change the carbon and hydrogen. That gives more hassle. We only want to change oxygen. So in this case, we're going to change the number of oxygen. Okay. Now we only need to add 1 more oxygen. Now if we change this number to 2, we add 2 more oxygens. So what we can do here is to put this coefficient 1.5, right? So in total, we need to have 4 oxygens minus the only oxygen from the first compound. We left over 3 oxygen atoms. And then the coefficient needs to be 1.5. So a coefficient can be decimal, but it's only suggested for elemental substance, because when you change that, you don't need to change any other atoms. If you put 1.5 in front of methanol, it adds you more, that's more difficulty in calculating the number of atoms here and there. So I would suggest only to add a decimal coefficient when you have an elemental substance, when you need to do that for elemental substance. All right, for now we can count atoms before and after reaction. Now everything matches, that's great. So we're filling the rest of the coefficient as default 1. And now just check again, so it's matched. The number and type of atoms matched very well. So that's great. I mentioned the decimal coefficient before. So the coefficient can be fractions or decimals, it's fine. Like theoretically it's good, it works. But whole numbers are preferred. So now we have 1.5. We want to make the smallest whole number possibly it can tune into. So we can change all coefficients at the same time. Multiply everything by 2. Then you make 1, 1.5, 1, 2, to 2, 3, 2, 4. Okay, so all coefficients in a balanced chemical equation, it has to be balanced first. In a balanced chemical equation can be multiplied and divided by a common factor, which means if you want to multiply of one coefficient, you need to do the same thing to the rest. And everything should be multiplied and divided by a common factor altogether. It's like you can treat a chemical equation more or less like a math equation. You can treat these arrows as an equal bar. So if you have x equals to y, what you can do is to multiply the coefficient, both of them by 2, or divides by 2, then 2x equals to 2y. So when you do this change of the coefficient, make sure you do it all together with all other coefficients. After we do the change, we can double check if the type of atoms are balanced before and after, in case any mistakes are made. So in this case, we have 2 carbons before after reaction, 8 hydrogens before after reaction, 8 oxygens before and after reaction. It's perfect. It's balanced very well. So now we have a balanced chemical equation. Finally, check all the coefficients. If a coefficient is 1, we can leave that out. All right, with the 6 steps, we can balance a chemical equation. Let's take a look at a question. Write a balanced equation for each of the following. A characteristic reaction of group 1A elements, chunk of sodium, react violently with water to form hydrogen gas and sodium hydroxide solution. What's a chemical reaction, chemical equation corresponding to this reaction? Okay, let's take a look at it. First of all, you need to identify what are reactants, what are products, and you need to come up with the correct formula with it. Sodium is one of the reactant, as you can indicate by the word react. React with water, so reactants are sodium and water. And the word form indicates whatever after that are products. The hydrogen gas and sodium hydroxide solutions are products. So first, write out the unbalanced chemical equation with chemical formula. Sodium, it's elemental substance, so we just write Na here, and plus water that leads to hydrogen and sodium hydroxide. Okay. Then we can count how many atoms before and after reaction. Before reaction, we have 1 sodium, 2 hydrogen, and 1 oxygen. After reaction, we have 2 hydrogen plus 1 hydrogen that equals to 3 hydrogen, 1 sodium, and 1 oxygen. So showing that in this form. Then we can tune the coefficient. We need to add more hydrogen before reaction. Okay, so before reaction, hydrogen only comes from this water compound, and we need to boost up the coefficient before the water compound. Since this one is not elemental substance, I will not do the fraction for this compound. So we can try if we double it, if that works. So we can tune the coefficient. Now it's 1, we need one more, so we can make it 2. Then we can count all the atoms before and after reaction. When we make it 2 hydrogens, we make oxygens, also double the number of oxygens as 2. So now we have more hydrogens than before reaction than after. We also have more oxygens before reaction and then after the reaction. So we can keep tuning the factors. We just did something to hydrogen, so we can put it aside for a moment and focus more on this oxygen. We need to get 1 more oxygen, after the reaction. So we put coefficient 2 in front of sodium hydroxide and count all the atoms again. Because we put 2 in front of sodium hydroxide, we boost up sodium and we also get 1 more hydrogen for it. Now the hydrogen and oxygen are both balanced. We just need to add 1 more sodium before the reaction. And it's an elemental substance, so we can add it quite easily. Make this coefficient 2. We can check if all atoms before and after reactions are equal. They are. We have 2 sodiums before reaction, 2 sodiums after reaction, 4 hydrogens before reaction, 4 hydrogens from 2 places after reaction. Oxygen, we have 2 before reaction and 2 after reaction. So now we can make the coefficient the whole number, and the default coefficient is 1. So here is the balanced chemical equation. If you want, you can also indicate their status. Say sodium, you can put parentheses, put S as a solid, water, put L as liquid in parentheses, hydrogen, G as gas, and sodium hydroxide as aqueous solutions. All right, this is how we balance a chemical equation. I'll see you next time. Bye.